Welcome back, viewers. In this video tutorial, you're going to understand how this symbol is formed and what it means in essence. Also, you're going to understand the proof of the formula at the right hand side. Then thirdly, you're going to understand the reason why the two are equal to themselves. So let's begin without any further ado. So let's get started with this. So let's begin by considering a curve whose function is given by y equals to f of x. M1 is the slope of the secant line joining the 2 points on the curve, A and B. As you can see, A and B are 2 points on the curve. And this line joining the two of them is called a secant line. And the slope of that secant line is represented as M1. Now let's say we want to determine M1. We can use the definition of slope to determine M1. From the definition of slope, M1 is indeed equals to increase in y divided by increase in x. However, from coordinate geometry, we were able to learn a formula that can help us to determine M1 in different form. And that is M1 can also be equals to y2 minus y1, even though they are referring to the same thing, all divided by x2 minus x1. Now, earlier we said that y is a function of x, which implies that y1 will be equals to f of x1. Not only that, y2, y2 will also be equals to f of x2. Perfect. Now, suppose we let x2 minus x1 to be equals to change in x, as that's exactly what it means. Sometimes this change in x is referred to as delta x. So let me hold that a little bit. So let x2 minus x1 be equals to change in x. Now solving for x2, we can clearly have x2 to be equals to delta x plus x1, which can be rearranged as x1 plus delta x. Now since y2 is equal to f of x2, what I would like to do is to replace x2 with x1 plus delta x. And therefore, y2 becomes f of x1 plus delta x. Perfect. Now, earlier we said M1 is the slope of the secant line joining A and B. There's another line called a tangent line. A tangent line to a curve, unlike secant, it doesn't pass through or join 2 points. It only join 1 point. It only cuts 1 point. It's only passed through 1 point on the curve. And this is a visualization of it. So this line is called a tangent line as it only touches this curve at point A. And M2 is its what? Its slope. So now back to this. Let me call it equation 1. From equation 1, I just use that to explain what M2 is. From equation 1, let's replace y2, y1, x2 minus x1 with y2, we got that to be f of x1 plus delta x, then y1 f of x1, then x2 minus x1 plus delta x. So therefore, M1 now becomes f of x1 plus delta x, good, then minus f of x1, then everything divided by delta x. Now this whole expression or equation we are having right now is called the gradient function of a curve y equals f of x. So when they are talking about gradient function, you should know what they are referring to in essence. Now, suppose we keep point A, we keep it fixed. And now we begin to adjust the position of point B along the curve gradually such that it's approaching point A. Notice that the delta x will begin to decrease alongside as well, because when B is here, you can't compare delta x you'll be having to the entire delta x we are having before. Talk less of when B is here. As you can see, the value of delta x will be getting much more smaller as B is getting closer to A. Now, not only that, notice that the secant line will also be getting to be approaching the tangent line, as you can see. And in fact, when B is almost to A, the secant line becomes tangent line, and therefore they have the same slope. So as B is moving closer to A, then M1 will be tending to M2, and therefore M2 is said to be the limiting value of M1 as B is moving closer to A or as delta x is approaching 0. So M2 is said to be the limiting value of M1 as delta x approaches 0. And this is simply expressed mathematically as M2 equals to the limit as delta x approaches 0 of M1. But earlier we said M1 is equal to this. So that's of f of x1 plus delta x, okay? Then minus f of x1, then everything entirely divided by delta x. And this is what we call the derivative function. The first one is called the gradient function, which is this, but this one is called the derivative function. So let me call that equation 2. Now that's not the end. Now earlier we were able to say that x2 minus x1 is equal to delta x. Then this can be applicable to delta y as well, which implies that y2 minus y1 is also equal to delta y. But earlier, y2, as you can see on the board, y2 is this, and y1 is this, which simply means that f of x1 plus delta x minus f of x1 is simply equals to delta y. But in equation 2, I have something similar to that. So I will just switch this or flip it or get rid of it and replace it with this. So which implies that m2 equals the limit as delta x approaches 0. Now instead of this, I'm putting this, delta y over delta x. Let this be equation 3. But m2 is equal to m2. Either you use this approach, you will get the same answer to using this approach. So since they are equal, I'm going to set these to equal to this. Okay, and I'm out of space. Let me get rid of some thoughts. Okay, hope you're following the next section. So now, therefore, the limit as delta x approaches 0 of delta y divided by delta x will now be equals to this, the limit as delta x approaches 0 of f of x1 plus delta x, the minus f of x1, okay, divided by delta x. Very good. Now, this might seem a little bit complicated. Now, it is written in a more generalizable form. The left-hand side is now converted to this, equals to the limit as delta x approaches 0 of f of x1 plus delta x, the minus f of x1, and all divided by delta x. And that is where the symbol came from. So this symbol is read as the y dx. And it's simply the slope of a tangent line as the slope of a tangent line is approaching, as the change in x is approaching 0. Typically, it's simply the limiting value of the slope of a secant line joining two points as delta x or change in x is approaching 0. That is what the y dx is. So in case you ask now, what do you understand by the y dx? The y dx is simply the limiting value of the slope of a secant line that is joining two points as delta x is approaching 0. And that's it. And also, we now understand how this is formed. And this is the reason why they are equal to themselves. So this is called the y dx, and this is the value it is equal to. Now, finding the y dx using this concept is called the differentiation from first principle. Now, there are some other notations used to represent the y dx, and that is f prime of x and y prime. Okay, I have a video which I use to explain most of this. You can check it out in the description. So if you see f prime of x and y prime, it's still the same as the y dx. Okay, sometimes the y dx is referred to as the differential coefficient of y with respect to x. In fact, as you proceed forward in calculus, more about or more meaning about the y dx will be unfolded. But for now, just know that the y dx is either the derivative of a function y equals f of x, or the rate of change of y with respect to x, or the rate at which y is changing as x is changing. Okay, now you know how the y dx is introduced and how it is formed, in fact, what it really means, and also the reason why it is equal to the limit at which the given function, the limit of the given function as the time is approaching zero. Thanks for watching. If you have any question, let me know in the comment section below. Okay, thank you. Bye for now.